Hello everyone. In the previous module, we started the topic that is a Gauss theorem. The proof of the Gauss theorem was not in a CBSE syllabus, so we had started the applications of a Gauss theorem. The previous module we discussed the first application of a Gauss theorem. So today we are start that is a electric field, the second application of a Gauss theorem. The second application, the electric field due to a uniformly charged spherical shell. For this we will consider a sphere, that is this one, the center O. Here the radius of this sphere is capital R. We will place the capital positive charge is placed around it. Secondly, we will consider another sphere whose radius is small r. We will consider a Gaussian surface area, that is ds. At the point P, we have to find the electric field. The E is the electric field because this is a positive charge, so electric field will be the outwards. This is according to the Gauss theorem, E dot ds is equal to q upon epsilon naught. The angle and electric field, the surface and the electric field both are in the same direction, so the angle between them will be 0 degree. E ds cos 0 is equal to q upon epsilon naught. E ds is equal to q upon epsilon naught. Surface area, this is a sphere, so 4 pi r square is equal to q upon epsilon naught. E is equal to q upon 4 pi epsilon naught r square. This field is exactly the same produced by the single point charge. If we will consider the sphere, both the spheres are exacting at the same point, means the small r and the capital R both will be equal. If these are will be equal, you can write the electric field E is equal to q upon 4 pi epsilon naught r square. Only this small r will be represented with the capital R. We know that sigma is the surface charge density, that is sigma is equal to q upon 4 pi r square. It means the charge value is q is equal to sigma upon 4 pi r square. E is equal to sigma into 4 pi r square upon 4 pi epsilon naught r square. E is equal to sigma upon epsilon naught, and this formula is valid for the P lies on the surface of shell, means if both the spheres are lie at the same position. If point P lies inside the surface, inside the spherical shell, means small r is very smaller as compared to the capital R. It means we can consider the inside the Gaussian surface there is a no charge, so q is equal to 0, means the electric field will be 0. This question comes in the paper when if the point lies inside the spherical shell, the charge will be 0. Charge will be 0 means electric field will be 0, and you can plot a graph like this. When r is equal to capital R, the electric field will be the maximum electric field, and above this, when the r is greater than the capital R, then the electric field will be inversely proportional to r square, and this will be in the same. Next application is electric field due to a non-conducting charge sphere, solid sphere. This is not in your syllabus, so we can leave it. The next application is, but this graphs comes in a paper. Sometimes we are considering this is a value when small r is less than capital R. This value r is equal to r, and this is above this E is inversely proportional to r square. This graph is same as the previous graph. The next application is electric field due to a thin infinite plane sheet of a charge. We will consider a thin plane infinite sheet. Infinite, it consider of a positive charge dq. We will consider Gaussian surface ds. If charge is a positive, electric field will be the outwards. Here E and ds both are in a same direction. Here the ds electric field is in this direction, and ds will be in this direction, so we will consider the angle between them will be 90 degree. We can write the formula according to the Gauss theorem. Phi is equal to surface integral of E dot ds. This is due to the edges only, note their part. E dot ds is equal to E ds cos 0, because both are in the same direction, angle 0, E ds. ds, here is a surface, that is E. We are having a two surfaces, that is 1 and 2 edges. E dot ds. So there will be a no contribution from this side, because both angle between them will be 90 degree. Now according to the Gauss theorem, phi is equal to dq upon epsilon naught. E into 2ds is equal to dq upon epsilon naught. E is equal to dq upon ds and 2 epsilon naught. This sigma this will become the sigma dq upon ds. Sigma is equal to surface charge density. You can write dq upon ds, sigma upon 2 pi epsilon naught. So it is independent of the r. It means if the infinite plane sheet has uniformly thickness, the surface charge density of uniform is same on both the surface area. So the total electric field will be E is equal to E1 plus E2. E is equal to sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught, and you will get the total electric field will be sigma upon epsilon naught. The next topic is, that is electric field due to a too thin infinite parallel sheet of a charge. This is the last topic of a 1C, that is electric potential and Gauss theorem. We will consider two infinite electric parallel sheet of charges at the region 1. This is the region 1, this is region 2, and this is the region 3. These region 2 lie in between these two. At the region 1, electric field will be minus E1 minus E2. This is minus E1 minus E2 minus sigma 1 upon epsilon naught minus sigma upon epsilon naught. Sigma 1 plus sigma 2 upon 2 epsilon naught. Here the reason 2. Reason 2 means E1 is in this direction and E2 will be in the opposite direction, E1 minus E2. Put the value, you will get the result. Simultaneously in the reason 3 E is equal to E1 plus E2. Both are in the same direction. Put the value and you will get the result. Some special cases we can consider. The case 1, sigma 1 is equal to sigma, sigma 2 is equal to sigma. Again E1 is equal to minus sigma upon epsilon naught, E2 is equal to 0, so E3 will be sigma upon epsilon naught. Second special case we can consider, sigma 1 is equal to sigma, sigma 2 is equal to minus sigma, E1 is equal to 0, E2 is equal to sigma upon epsilon naught. Again E3 will be 0. That was the last topic of E. Thank you.